All right, in this video, we're going to talk about section 2C, dealing with problem-solving hints. Now, back in section 2A, we talked about the understand, solve, explain process, and that provided a framework for solving problems. Now, here we have 8 general hints that can be helpful when solving problems. Okay, now, this is just 8 of those hints. You're not going to be you won't be able to use all 8 of them, but these are just some ideas that you can use when you're solving particularly word problems. The first one would be that you might have more than one answer. I don't know if you were able to solve, equations like, let's say x squared is equal to 4. And I can show you this. Let's illustrate this on paper, like this equation, x squared is equal to 4. Now, in that case here, this type of equation does have 2 answers. One of them would be x is equal to a positive 2, because you want to find out what number squared would give you 4. And 2 would be one possibility, because 2 squared would be 4. And also, negative 2 is another possibility, because negative 2 squared is also 4. So in this case here, there may be more than one answer to a problem. Also, hint number 2, there may be more than one method. Okay, you might end up solving the problem one way, but another student could solve that same problem using a different approach. Okay, so there can be more than one method to solving a problem. Also, use appropriate tools. Okay, sometimes you may have to draw a picture. You may have to use your calculator to calculate more complicated values, more difficult values, which you can't be able to do in your head. Also, consider similar problems. That's hint number 4. Also, consider equivalent problems with simpler solutions. Okay. Another hint would be approximations. They can be useful. Sometimes approximations would be best to use in order to solve a particular problem, and then try alternative patterns of thought. And then the final hint is just don't spin your wheels. If the problem is a little bit complicated, you might want to push it off to the side for later and then come back to it. That way of solving that problem might come to you. I've had to do that before. Just put the problem away, push the problem off to the side, and then when I come back to it, I was able to complete that particular problem by coming up with the answer to it. All right, now, pretty much these examples I'm going to give you are just word problems. They're not going to be in any particular way using all 8 of these hints, but these are just going to give you some examples or some idea of how to do the actual ones in the homework for section 2C. All right, so problem number 1, or example number 1, you want to decide whether the statement makes sense or is clearly true, or does not make sense or is clearly false. In this case, whether it's a problem in mathematics or something else, I always find it's best to complete the work by looking back to check, interpret, and explain my solution. In this case, that particular statement will make sense, because when you're solving a problem, you want to complete the work the problem out. And once you get your answer, you want to look back and do some check to see if that answer is the appropriate answer to that particular problem, if it makes sense. Also, try to interpret what that answer is and explain how you got it. Okay, so that statement would make sense. The second one is this: decide whether the following statement makes sense for its clarity. Decide whether the following statement makes sense or is clearly true, or does not make sense, or is clearly false, and explain your reasoning. In this case here, mathematics requires precision, so approximation should never be used. Now, we did talk about hint number 6, dealing with approximations that can be useful. So this statement here would not make sense. Okay, because most real problems do involve approximate numbers. Real life problems do require approximate numbers, not precise numbers. Okay. All right, now let's go on to this problem. Example 3. A toll collector on a highway receives $4 for sedans and $7 for buses. At the end of the 2-hour period, she collects $148. How many sedans and buses pass through the toll booth during that period? And you're going to list all possible solutions. So this is one of those cases where there may be more than one answer, which was hint number 1. And we're going to find all the possible solutions to this situation. Now, we're told that she collected $148 in a 2-hour period, $4 for sedans and $7 for buses. And these are all the possible choices. So we're going to run through each one of these to find out which one of these will satisfy that she collected $148. Let's start with this one, 23 sedans and 8 buses. Keep in mind the sedans are $4, so 23 times 4, and then plus 8 buses at $7, 8 times 7. Now, in this case, you do get $148, so that's one possible choice. 23 sedans and 8 buses. All right. Answer B, 9 sedans and 16 buses. Well, 9 sedans at $4 plus 16 buses at $7. So it'll be 9 times 4 plus 16 times 7. That also gives you $148. So we can select this one as well. Part C, 4 sedans and 19 buses. Well, 4 sedans at $4, 4 times 4, plus 19 buses at $7, 19 times 7. This gives you $149. So C would not be a choice. 4 sedans and 19 buses would not be the appropriate choice. Now, what about 32 sedans and 3 buses? Well, that's 32 times 4 plus 3 times 7. I'm sorry. 32 times 4 plus 3 times 7. This gives us $149, so that would not be the correct choice here. And what about E? 0 sedans and 21 buses, so 0 times 4 sedans, and then 21 times 7. That's going to give us $147 and not $148. So that would not be a good choice. Now, what about F? 2 sedans and 20 buses. 2 sedans at $4 each, plus 20 sedans at $7 each. That does give us $148. So we'll select that one, 2 sedans and 20 buses. All right, G, 18 sedans and 11 buses. Well, that's got to be 18 times 4 plus 11 times 7. That gives us $149, not $148. So we cannot select this choice. What about 16 sedans and 12 buses? That's 16 times 4 plus 12 times 7. That would give you $148. Okay. So one choice, that's another choice, 16 sedans and 12 buses. What about 30 sedans and 4 buses? So this is 30 times 4 plus 4 times 7. That's also $148. So 30 sedans and 40 buses is another choice where we will get $148. And also 37 sedans and 0 buses. 37 times 4 plus 0 times 7, 148. So the ones that I have checked are all the possible solutions for the number of sedans and buses passing through the toll booth during that 2-hour period where the collector collected $148. Okay, so that's an example of a problem with more than one solution. Okay. All right, let's take a look at example number 4. Suppose you run 4 miles from your house to a friend's house at a speed of 5 miles per hour. When the time comes to return home, you're tired and walk the same 4 miles home at 3 miles per hour. Here we're going to answer parts A through D. Starting with part A, how long did you spend running to your friend's house? All right. If you recall, I don't know if you know this, but there's a formula for finding the distance. And that's usually going to be the rate that you travel multiplied by the time that you travel. All right. Now, in this case, we're going to find out how long did you speed run to your friend's house? We're looking for the time this time, so we're going to modify this a bit. The time is going to be the distance. And let me change that word rate to speed. Okay. So the distance is going to be speed times the time. So the time would be the distance divided by the speed that you're going. So in this case here, you run 4 miles at a speed of 5 miles per hour. So the time there would be the distance that you traveled, which is 4 miles, divided by the speed, which is 5 miles per hour. Now, if you recall in division, when you divide, you always multiply by the reciprocal. So this is going to be 4 miles over 1 times the reciprocal of 5 will be 5, 1 over 5. So it's going to be 1 hour over 5 miles. Here the miles divides out. So that means we got 4/5 of an hour. Now here they want this as a decimal rounded to the nearest tenth. So using your calculator, you'll do 4 divided by 5. That would be 0.8 hours. All right. Okay. How long did we spend running to our friend's house? It'll be 0.8 hours for that answer. And then part B is how long did you spend walking home? So again, the time, this time is going to be the same 4 miles. But here we're going to divide by 3 miles per hour because you're tired and you walk the same 4 miles at a rate of 3 miles per hour or at a speed of 3 miles per hour. Now, we again multiply by the reciprocal, so it'll be 4 miles over 1 times the reciprocal of 3, which is 1/3. So this is actually going to be 1 hour over 3 miles. Okay, we invert the units as well. So that way your miles divide out. This will be 4/3 of a mile. And if we write that as a decimal to one decimal place, which is to the nearest tenth, this will be 1.33 repeating, but to the nearest tenth to one decimal place, 1.3, and this should be hours because the miles divided out. You're left with a unit in hours. So it'd be 1.3 hours. So that's that answer to part B. This person spent 1.3 hours walking home. And in part C, is it true that the average speed for the round trip is the average of 5 miles per hour and 3 miles per hour, which is 4.0 miles per hour? But the hint is, did you spend more time traveling 5 miles per hour or 3 miles per hour? All right. If you look at these times here, we see that this person spent less time running at 5 miles per hour than they did walking at 3 miles per hour. So in this case here, to answer that question would be no, because less time is spent traveling at 5 miles per hour. So it's not true that the average speed for the round trip is the average of 5 miles per hour and 3 miles per hour, giving you 4.0 miles per hour. And here's part D. What is your average speed for the round trip? Well, here's how we compute that. This person ran 4 miles, and then when he went home, he walked 4 miles. That's the round trip. Because round trip is from leaving from your home to your friend's house and then leaving from your friend's house to come back home. So in this case here, 4 miles plus another 4 miles. That's a total of 8 miles that this person has traveled, round trip. Okay. Let's say you're visiting, going on a trip. It's usually a round trip. You go from your home to the vacation site, and then you leave the vacation site to go back home. That's your round trip. 4 miles is 8 miles. And the time traveling to your friend's house or running to your friend's house is 0.8 hours, plus the time that you spent going back home or walked home, that's 1.3 hours. You add those, that's going to be 2.1 hours. That 8 miles represents the total distance, since it's a round trip. The 2.1 hours represents the total time. All right. So now to find the average speed, the average speed is going to be the total distance, which is 8 miles, divided by the total time, 2.1 hours. Because average speed has to be in miles per hour, so you have to divide the total distance by the total speed. So if I do 8 divided by 2.1, I would get approximately to one decimal place, as they say in the problem, to the nearest tenth, 3.8 miles per hour. So the average speed for the round trip is about 3.8 miles per hour. Okay. And the last example in this video is this. It takes you 57 seconds to walk from the first floor or the ground floor of a building to the third floor. How long will it take you to walk from the first floor to the sixth floor at the same pace, assuming all floors have the same length? All right, one way of doing this would be to go ahead and use appropriate tools. Sometimes you may have to draw something. And here I'm going to just do this first floor, second floor, third floor. All right. So here you're going from the first floor to the second floor, that's one interval. And then from the second to the third floor, that's the second interval. And you did this in 57 seconds. So here, if I do 57 seconds, divide that by the two intervals that you see. As a decimal, that would be 28.5. 28.5 seconds per interval. Okay, I can verify that on the calculator. 57 divided by 2, 28.5 seconds per interval. Now I'm going to use that to find out how long will it take us to walk from the first floor to the sixth floor at the same pace. So we're going from the first, then second, third, fourth, fifth, and sixth floors. From the first to the second, that's one interval. From the second to the third, that's 2. From the third to the fourth, that's 3. From the fourth to the fifth, that's 4. And finally, from the fifth to the sixth, that's 5. So there are 5 intervals here. And we want to know how much time it takes for us to get from the first to the sixth floor. Well, our average speed was 28.5 seconds per interval. Let's multiply that. You're going to see intervals divide out. So we're going to get an answer in seconds. So if I do 5 times 28.5, you'll get 142.5 seconds. Okay. So to answer that question, it would take us 142.5 seconds to walk from the first floor to the sixth floor, assuming that all the floors have the same length and assuming that we're going at the same pace. Okay. All right, so that does conclude this video on section 2C, dealing with problem solving hints. All right, the homework should be in my math lab for you to complete. Feel free to ask questions if you have, or reach out to me if you have questions on any of the problems that were presented in this video or any of the homework problems in my math lab.